Technical background information of the diesel issues at Volkswagen. A vehicle with a petrol or diesel engine burns fuel. Combustion always creates pollutants. The emissions. Legal limits apply to a number of components of the emissions. We will show you how these elements are removed from a diesel engine's exhaust gas step by step. The combustion takes place in the cylinder and drives the piston. Here, the emissions are generated. The nitrogen oxides, the so-called NOx, are part of the emissions. They are already minimized inside the engine. This is exactly what exhaust gas recirculation does by feeding part of the exhaust gas back into the cylinder. This reduces the combustion temperature, giving rise to far fewer NOx. After the exhaust gas has left the combustion chamber, it drives the turbocharger and moves on to the exhaust gas aftertreatment. In this compact unit, the exhaust gas encounters the oxidation catalytic converter. This converts the carbon monoxide and hydrocarbons left over after the combustion process. The products: CO2 and water. In a next step, the exhaust gas reaches the diesel particulate filter, which eliminates the soot. The process described here reliably fulfills the exhaust limits of the former Euro 5 standard in Europe. The limits regulate both the diesel particulates and the nitrogen oxides. However, reducing them both results in a technical conflict, since with a diesel engine, a reduction of the particulates emissions automatically leads to increasing NOx emissions and vice versa. Therefore, to comply with stricter NOx limits such as Tier 2 Bin 5 in North America, exhaust gas recirculation alone is insufficient to limit the NOx. The NOx have to be reduced actively. There are two technologies for this exhaust gas aftertreatment. One of them is the NOx storage catalytic converter, which stores the nitrogen oxides. When it is discharged, it releases CO2 and nitrogen, as it makes up 78% of our natural atmosphere. Especially in larger vehicles, another technology is used, the SCR system. Here, AdBlue, a water-based urea solution, is injected into the exhaust gas. After its conversion, water and again nitrogen are generated in the SCR catalytic converter. An important part of a modern engine is the engine control. Its complex software processes the signals of many sensors in the vehicle and ensures that the cars offer good performance profiles with the lowest possible consumption and comply with the required exhaust standards at the same time. Testing determines whether a vehicle fulfills the legal requirements. The vehicle runs with a defined speed curve while the exhaust gas values are being measured. If the model fulfills the required specification during its type testing, then every vehicle in the series is certified for this emission standard. A vehicle needs to recognize that it stands on the dynamometer, otherwise its ABS would block the drive wheels, for example. Software installed in vehicles fitted with EA189 diesel engines adjusts the emissions during dynamometer tests by changing the exhaust gas recirculation rate. This ensures that compliant emission levels are reached only during the test cycle. This mode is deactivated under normal operating conditions. The planned software update will no longer include this deactivation. We are currently developing technical measures to ensure that the affected vehicles meet the legal requirements. These differ for EA189 engines in Europe depending on the engine type. The 2.0 and 1.2-liter engines get a software update. Within this process, the deactivating software is removed and new engine control software is installed. This will take about 30 minutes. For the 1.6-liter engines, the flow towards the airflow meter is additionally improved. The airflow meter determines the mass of the intake air. With this, the engine control doses the fuel quantity and regulates the exhaust gas recirculation rate. A new component, the flow straightener, is set into the air intake. Its grid calms the flowing air in front of the sensor, which delivers improved signals as a result. With these improved signals, the engine control can reduce emissions actively. Further developed software features are added. They ensure a more accurate control of the combustion. This refitting will take no longer than 1 hour. The refitting measures are currently adapted to each engine and each affected vehicle type. All vehicles with EA189 engine type are technically safe and ready to use. The refitting process will start in January 2016. We will write to our customers to inform them in due time. Find more information at Volkswagen.com.